Good afternoon. How's everyone doing? Good? I'm gonna start with a question, if I may. So please put your hand up if you've heard of somebody called Mikko Hyppönen. Mikko Hyppönen? Yeah, good number of people. I thought it'd be a safe question with this audience. So Mikko is a bit of a legend of the cybersecurity community. So Mikko was the CTO for F-Secure, the Finnish antivirus company. Worked in cybersecurity for around about 30 years, delivered some fantastic TED Talks, some really rousing talks on the nature of cybersecurity and state of the internet. But Mikko announced this year that he was leaving cybersecurity and he was going to join a counter-drone startup, which at the first look seems to be quite a significant move. I mean, what has somebody who's worked in antivirus got to offer in terms of what is essentially an air defense problem dealing with drones? But the more you think about it, the more similarities there are between drones and antivirus. Both are fast-evolving threats. Both are threats that operate in this sort of gray zone activity of hybrid warfare. Both have a detection challenge, they have a mitigation challenge, they have an investigation challenge, and both require skills of digitally savvy investigators in order to understand actually how are these things operating. So I'm going to try and unpack that particular challenge and overlap a little bit more through this presentation. And where I want to start was a good understanding of who are the actors behind these various drone incidents that we hear about all the time in the news today. And I've done a lot of presentations on the cyber threat landscape, so this is always a good place to start, is understand the motivation of who's behind this particular threat. And in drones, this looks an awful lot like it does in cybersecurity. You've got the lone actors, very similar to the AP teens that Manny was talking about earlier. So these are driven by fame, wanting to kind of get fame for themselves, driven by curiosity, driven by a need to make a point, to kind of prove they can get through existing security and defenses. There was an example a few years ago of somebody who landed a quadcopter on the deck of one of the Royal Navy's aircraft carriers, right beside the F-35s that cost over 100,000 pounds each, and yet they managed to get onto the deck of the aircraft carrier and land. And again, this probably wasn't a criminal actor, it probably wasn't a nation-state actor, just somebody who thought, I bet I can put my drone on the deck of that aircraft carrier, and of course did manage to do that. Criminals are picking up drones as well. So these are often used for smuggling, like getting drugs into prisons, for example, but also being used increasingly to attack law enforcement. There's a great article in the Economist magazine this week on how drones are being used by criminal groups in Latin America and Colombia and in Brazil to attack law enforcement, and they're learning all of the lessons from Ukraine to build really potent capabilities to target law enforcement. And of course, there's the state actors. And predominantly, this is military actors who are building drone capabilities for surveillance, for intelligence purposes, for logistics, for carrying equipment, for example, in the front lines in Ukraine, and for attack. So drones that are built with attack capabilities in them. The different types of drones can be categorized in lots of different ways. You can do it by kind of the weight and the size of the drones, but one way I like to categorize them is by, I guess, the sort of origin of them. So there is probably the majority of drones out there are commercial off-the-shelf. Around 80% are off-the-shelf drones that you can buy in shops. And these are typically the likes of the DJI Mavic small drones or DJI Phantoms, sort of larger, more professional drones, more sophisticated cameras and so on within those. The custom ones are really interesting, though. These come a lot of the time from FPV racing, so first-person view quadcopter racing. You can buy kits to basically build your own drone, and you can customize it. There's lots of open source protocols that you can use for communications, and then you can customize with whatever payloads you want on those. So a lot of the IED type, the flying IED type drones that we see being used in Ukraine, they come from these types of technologies. And then finally, the military type, so the ISR drones, like I mentioned, such as the Orlan 10, or these infamous Shahed 136s, the delta-shaped drones that have been used predominantly in Ukraine. Just dwelling a little bit on Ukraine. So there's lots of different types of drones that are being used there. The ones that have been most prolific over, say, the past year have been these one-way attack drones that have become quite dominant. And this chart shows the increase in those and the increase in threat quite significantly. So what it shows is the use of ballistic missiles and drones as attack. And if you go back a couple of years, it was kind of half and half. You had about the same number of missiles being used as drones. But over the past year, the number of drone attacks has increased substantially. So now Ukraine is seeing up to 800 attacks per day using some of these drones. And it's different from day to day. Some days they get almost zero. Some days it's hundreds of attacks. And that is deliberate so that when they have these waves of attacks, they can overwhelm the existing air defense systems that are put in place to try and defend against those. These Shahed-type drones are the most prolific. So they're not actually Shaheeds. That's not really the right name for them. In Russia, they're called the Geran. They're based on the Shahed, which is originally an Iranian design. But they are massive. They're huge pieces of kit. They carry up to 50 kilograms of high explosives. So that will blow a hole in the side of any building that it hits. And they got ranges over 2,000 kilometers. People talk about the price point, and it's all relative. I mean, these are not kind of hundreds of pounds worth of drones. These cost about the same price as a family car. But Russia is really ramping up its production of these. So they've got a target of 40,000 of this type of drone for this year. And there's a few other kind of types that are targeting about 20,000 of those. Altogether, that's around what we were seeing in the previous graph, which is what Ukraine is seeing in the daily attacks. What these actually look like in practice, we know about, because Russia's produced some propaganda videos showing inside their drone factories. And so this is a factory in Alabuga, deep inside Russia, where they're actually producing the Geran drones. And all of the components are sourced locally. So whilst the design is originally Iranian and probably some of the components originally from China, they've made sure that they've localized the supply chain so they can build the motors, they can build the propellers, they can build the fuselages, they can build all of the electronics inside to be able to ramp up that production. If you're interested in how many you can see in the image in the factory, it's around about 400. So that's probably about 2.5 days worth of drones within that image in the factory. So what do the defenses look like? It's a bit of a mixed picture at the moment. So it's fair to say defenses have been kind of scrambling to catch up with this threat over the last few years. You've got countermeasures that are what you might call point solutions, literal point solutions in this case, like drone guns that you point at the drones. And these are often using electronic warfare type techniques to jam signals. So they will work well against something like the DJI drones, which is a very well-known command and control signal. And you can code that up into the jammer, and it may work to a certain range. When you get beyond the COTS drones, the DJIs, and you're into more custom drones where you can use different protocols, then you have to be able to target different frequencies. And so the backpack with the 8 aerials, I suspect that's one of these systems where you've got 8 different radios all coded to jam at a different frequency. Fine if you've got 8 threats at different frequencies coming at you. What if you've got 10? Or what if the threat is using frequency hopping and you can't just jam a particular frequency? So that's where people get more into the kinetic-based solutions, so what you see on the right-hand side. Gun-based systems or missile-based systems. Challenge there, of course, is these are very expensive. So the Patriot missile system that's shown on there, that's $3 million per missile, and those are huge, sophisticated systems, not at all intended for counter-drone, though they will work against them. So that's the landscape from a kind of a traditional sort of, I guess, military type perspective. But of course, we're a cybersecurity community. So we want to know, what do these actually look like within the system, and how are these actually controlled? So it's interesting to look at the subsystems from that perspective. So this is a schematic of a typical drone system. And what you've got inside this is you've got a flight controller. That's essentially the brains of the drone. And that could be running on something like a Raspberry Pi. It could be running on an STM32 microcontroller. They often use open source flight controller software like RGU Pilot. And the flight controller is then connected to different peripheral systems. So it's connected to the motors, it's connected to the servos, it'll be connected to the payloads, and of course it's connected to the transceivers. And the transceivers are where it gets a little bit more interesting from a cybersecurity perspective. So there's three on this schematic. So you've got the command and control transceiver that's used to receive the instructions. You've got the video transceiver, so if there's a video feed coming off the drone. And you've got the navigation, the GPS or GNSS receiver. So that one's just one way. But it's interesting again, from a cybersecurity perspective, there's no firewalls on drones, right? So there's no protection from the outer world. If you know what frequency or what modulation the transceivers are using, you can just talk to them. They have no other security there. And inside the drone, again, no security, no segregation of systems. So if you get access to the transceiver, you get access to the flight controller, you get access to the flight controller, you get access to everything on that system. So the state of security in drones is not like in enterprise IT. It's still decades away from even what we'd be familiar with on our mobile phones. Really, really quite basic. So I'll share with you a case study of what it looks like from a cybersecurity perspective to interrogate one of these drone systems. We've done a lot of work in this space over the last couple of years, most of which I can't talk about, I'm afraid. This is one I can share. Some of the examples we've looked at have been on satellite systems, so low Earth orbit satellites, and they're basically exactly the same in terms of the layout. I mean, satellites are kind of like higher flying drones, so nothing particularly different there. But this particular case is it's a long-range transceiver that is popular with ISR drones. It can be used out to 100 kilometers in range, so quite effective from that perspective. It has good transmission security, so transmission security is how good the security of your link is, essentially. And in this case, they use frequency hopping, so spread spectrum frequency hopping. And they've also got good communication security, so good security on the actual payload of what's being communicated. But there was a few mistakes in how they'd implemented the crypto that allowed us to make a proof of concept attack. So the first challenge you get when looking at drones is, how do you get your hands on the firmware? Unfortunately, it's not like in antivirus where somebody gives you a binary file. You've usually got a physical system, and it's like, okay, how do I get my hands on the actual software code? Sometimes you can be lucky. The manufacturer of the flight controller, let's say, or the transceiver may not be so strong from a cybersecurity perspective, so they may just publish the firmware on their website. So it's open to just go and download, and there you've got the firmware. You can do the analysis straight away. Most of the time, this isn't the case, and you've got to actually extract the firmware off of the board. So there, you're looking for ways that you can attach pins onto the board and dump the firmware. Sometimes that's possible. Sometimes it's been locked down, and that's not possible. The other sort of worst-case scenario is where you've actually got to desolder the chip and physically take it off the board. And there you want to really have a friend or colleague who does soldering for a living, because that is not a job that you take on lightly. It can just damage the board permanently. In this particular case, we were lucky, and the firmware was available on the manufacturer's website. However, it was encrypted. So what the team did was they managed to find another version on the manufacturer's website that was actually unencrypted, a legacy version of the same firmware. Unfortunately, in this case, they'd actually used the same technique or some same key within that code that allowed us then to compute a key to unlock the current firmware. So we got access basically to the current firmware through the legacy firmware. Once you got the firmware, then it's into doing reverse engineering. So anybody who's done malware analysis or seen somebody do malware analysis would be familiar with what this looks like. It's loaded up into Ghidra, IDAPRO, generate the pseudocode, and then go through looking for how is this actually been implemented, and from there, how can we discover some security flaws. So in this particular case, like I said, the manufacturer had used AES 128, so reasonably good attempt at good security, but the way that they'd actually implemented this had a flaw in it. So basically, the frame of the payload is encrypted with the AES key, and then they top and tail it with a header and a checksum, so kind of no problems up to this stage. But then the whole frame, so the whole thing, gets XORed again with the same AES key. And the problem comes from the fact that there's a static and easily guessable header that they've used. So you can guess or brute force the header. You know what the encrypted header looks like with the XOR. You can then combine the two to recover part of the AES 128 key. And because these frames were varying in length, you do that over a few frames, you can recover the whole key. So that was basically how we were able to recover that key, and with that key, you can do a lot of malicious things. So once you've got the key, you can, you do need to, sorry, should have mentioned, you do need to also get the frequency hopping table. So that's also within the firmware. But that, in this case, was a short and reasonably static frequency hopping table. So with that, you can then eavesdrop on commands. You can get the telemetry from the drone. You could intercept the video feed, things like that, if you wanted. But you can also go a bit further. You can inject commands as well. So you can fully take over control of this drone. You could do something a bit more subtle, like what we call context-specific denial. So if the drone goes into a particular area you don't want it to be in or see a particular thing, you can make sure that the video feed, let's say, cuts out, so the drone would have to return back out of that area. So understanding the security of these things through reverse engineering is quite important. So that's an example. But in order to understand where we're going with the drone threat, it's important to ask, how did we get here to where we are in the first place? And to me, one of the key technology evolutions that's driven drone technology to where it is today is smartphones. So if you look back to where the sort of era of smartphones, around about where the iPhone came out in 2008, a couple of key pieces of technology that were involved in that were miniature electronics for gyroscopes and accelerometers. Useful for your phone if you're carrying it around, but critical for drones. And that small miniaturization of the electronics is what enabled quadcopter drone technology to then emerge a few years later. And what we've seen then subsequently is other bits of technology from smartphones coming into drone technology. So things like the high-resolution cameras that initially were built for phones, now available in drones. Multi-band GNSS, so GPS plus all of the others that can now be used. Lithium polymer batteries, so batteries that are, again, smaller, more durable, higher charge density, again, developed for smartphones, but now being used in drones, and so on. And the latest things that are coming through advanced CPUs and GPUs into smartphones is, of course, edge AI and computer vision, object recognition, which really I think is only still emerging in smartphone technology. But that is going to be a critical enabler for more drone advancements over the coming years. So the more drones are able to interpret from their environment through computer vision techniques, but also object detection and smart stuff coming from smartphones will enable greater evolution of the drone threat. The other critical technology that I think is going to be quite impactful is what's kind of formerly known as non-terrestrial networks, but it's basically 4G or 5G or 6G technology in future being provided from space. So low Earth orbit satellite constellations like Starlink providing 4G telephone signals on the ground. That technology is already here for smartphones. It's already miniaturized for smartphones. It will be a key enabler for the drone threat in future years because it's going to break the link between that localized ability to control something with a radio transceiver and a drone which could be deployed on the other side of the world, but you're able to connect to it over the internet, over the SATCOM links. So that's going to be an interesting one to watch. Again, hasn't really come into the drone technology landscape yet. There's also a few other, I guess, more drone-specific evolutions that are worth watching and have some probably predictable trends. So a lot of people talk about swarms, drone swarms. It's not really a thing yet. We don't really see that much evidence of that being used. And partly that's because drones are controlled one-to-one. It's one operator to one drone. When you think about a swarm, it's one operator to lots of drones, and that's, you know, outside of these drone displays, that's not something you really see in practice. However, it's starting to come. So some of the recent Garan drones, ones that I showed earlier, that have been downed in Ukraine, they found mesh radios within those, and those mesh radios allow the drones to communicate with each other whilst in flight. So what the attackers are probably doing with these is using a, let's say, forward drone to pass a video signal or some telemetry back to other drones and ultimately relay it all the way back to the operators so that they can see if their attack, if their target is still there, and then they can reprogram the subsequent drones to go to different targets based on what's been relayed back. Now, from a cybersecurity practitioner perspective, I'm like, that's a botnet. That's just a peer-to-peer botnet, albeit with mesh radios and drones. So we can expect that this will come because the technology is starting to come there, but also probably all of the kind of security issues that come with botnets that we're familiar with from cybersecurity will also appear within those systems as well. The second trend that is already happening is, of course, proliferation. So military drones that have been developed and battle-tested in Ukraine are starting to appear elsewhere. Again, in Colombia, for example, through the cartel gangs who are getting some of that technology and weaponizing it against law enforcement, but also in state-on-state conflict. So in the India-Pakistan air war that happened earlier this year, you know, there was a lot of talk about the traditional kind of combat aircraft that were used in that, but there was a heavy use of drones and drone technology that had come, again, from people supplying into Ukraine and then taking that technology into other battlefields. So this proliferation risk is starting to emerge, and it's going to accelerate once there's peace, because people are going to have to do something with all of this drone technology that's been produced. So that's something for us to keep an eye out on. And then the third thing that's worth reflecting on is, I've been talking all about aerial drones, but actually drones as a category isn't limited to flying aerial drones. Drone boats have also had a significant impact in Ukraine as well as in the Red Sea. These are an obvious thing for smugglers to use as well. I mean, these awful attacks that are happening off the coast of Venezuela with these drug cartels that are using boats, they're naturally going to go, right, how do we just remove the people from the equation and we just have our drone boat that's guided through some clever system to send it to where it needs to be, or a drone submarine that's just below the surface. So that's an obvious place for criminals to go to. The other thing that's coming is, of course, humanoid robots. So anybody who's listened to Elon Musk talking about what he's excited about at the moment and the technology that they're developing at Tesla, they're putting a lot of effort into creating humanoid robots at a price point that will be affordable to the masses, so kind of $20,000, $30,000. Now, you can discount it and say, oh, that's just Elon saying, you know, this next thing is coming. But he often is producing what he says he will produce. So this gets very interesting from again, a threat actor perspective. Just think about the various different use cases a threat actor would have for humanoid robots. There's lots of them. Again, how do we interact with them from a digital perspective? How do we investigate them? It's very analogous to what we're seeing with the flying drone threat today. So to me, and I've kind of hinted at it already, malicious drones are just flying pieces of malware. They're just code that is up in the air with some, you know, physical rotors or whatever around it, or some humanoid robot system to move it around. But the brains of the system is a digital system, and if that's being used maliciously, well, that's just like malware. That's just code that is being written and programmed to be used maliciously. So I think there is an opportunity for us, from a cyber threat intel perspective, to bring our knowledge into this space and use it for good in terms of how do we understand this emerging threat, but then also how do we kind of help in terms of interrogating it. So digital forensics has got to have a key role in this. So how you get code out of systems in a secure, forensically sound way to be able to investigate it. Again, it's non-trivial. There are ways to do it. Have you lost the slides? I've lost the slides, but you can see them. So there are ways to do it that you can preserve the code. There's ways that you can easily destroy the code. You might have only one example of this particular system that's been recovered, possibly crashed or wet or somehow smashed because somebody shot something at it. So being able to get the code off of that to be able to actually see, you know, what was the program to do? Was somebody controlling it? Is there any kind of fingerprints to who's behind it as well? All of that is crucial. Reverse engineering. So once you've actually got the code off the system, you need to be able to reverse engineer it. Again, the state of security on these things is not very high today. We can expect greater effort around encryption and obfuscation and making life difficult for investigators. And again, those are all the skills that reverse engineers have to be able to get around that. Reverse engineering can also find vulnerabilities as well. So how do we take those vulnerabilities and responsibly create ways that we can produce attacks against those systems and get those into the hands of defenders as well? So how can you, not just jam a malicious drone that you see and not know necessarily is that going to fall on somebody's head, but how can you hijack control of that malicious drone and actually control it to take it down safely, you know, if it's over a stadium or a crowded area? I don't think anybody can do that today, but technically we should be able to do that. So that is an opportunity, I think, that is still ahead of us. Like I said, the connectivity will increase. So these non-terrestrial networks will mean that we've got global connectivity very soon on our mobile phones that people are going to use within drones and other systems. So with that connectivity, you know, these just become edge computing nodes that are on the internet somewhere. So what other kind of cyber risks come with that? You know, are people going to be able to use that to launch attacks? Are people going to be able to hack into systems that we want to defend through the internet? Again, we've not even reached that level of maturity yet. And I think some of this will evolve similar to how the cyber threat has evolved. So, you know, in the early days, it was quite basic viruses that were on the internet proliferating. An antivirus emerged as the mitigation for that, and of course, it's evolved into a huge field from that sort of early beginnings. But I think just to kind of summarize, you know, I think this is probably where Mikko Hyppinen is coming from, in that, you know, we're still really at the early days of this drone threat, and it's not necessarily about just what it looks like today, in the same way that, you know, the virus threat was not how cybersecurity would all look today. It all evolved over time into something that was probably quite hard to predict back then. But nonetheless, there are key enablers that we need to reflect on, so that the skill sets of the people will be useful as the threat and as the technology evolves. So how do we get the people who are good at cybersecurity today into looking at the drone threat for tomorrow? There was also key enablers as well. So even in the early days, sharing virus code among the antivirus community was common. We have nothing like that in investigating drones at the moment. So maybe we need some enablers of how we can responsibly share code from these different systems that can be used by the good guys to enable better defenses. And there is an urgency to this because, unlike in cyber, drones do kill people. And in fact, there's probably a lot of people who've been killed by drones over the last few years. And I don't want to dwell on too somber a note, but again, this is something that we probably need to look more closely at. How do we accelerate? How do we tackle this drone threat so that it isn't becoming out of control quicker than we can manage? So my ask as a community is that we continue looking at this. We look at the opportunities for how can we tackle this from a technology perspective, but also how do we tackle this from a community perspective? How do we enable greater sharing and exploring the art of the possible? Thank you.
Flying pieces of malware, you really have a turn of phrase. I think at the end of a long day, no one's going to forget that one. I'm going to use an old-fashioned cybersecurity term. You have DDoSed Slido. So there's going to be lots of questions. I hope you don't mind, because you really have attracted people's interest. So, first one, if AI guides a drone's behavior and its choices affect people on the ground, who carries responsibility for those decisions? And what safeguards keep the technology within ethical and legal limits? Yeah. A huge question.
I mean, there's a reason I start threat landscape briefings with these are the people, the different motivations. I mean, even if it's AI, there's still somebody behind it somewhere. So I don't know from a legal perspective, and I'm probably not the greatest person to ask from an ethical perspective either.
Oh,
but certainly
you're not that bad.
but certainly from a technology perspective, from a forensics perspective, I still like the analogy of digital breadcrumbs, and there's probably always some way to link it back to a person somewhere. So even if there's AI in the middle somewhere, there should be a clue as to who's behind it.
Right. Some techniques to identify command side channels for dumping the firmware. Any views on that?
Yeah. So the challenge with dumping the firmware. So on a board like STM32 microcontroller, you have a few options in terms of how you set the accessibility of the firmware. So it's either easy to read-write, I think it's easy to read, or it's completely blocked and you just can't read, and if you attempt to change it, it kind of wipes it. So that's where you get into side channel attacks. So you do some glitching. So you power the board up, you glitch the power so that you can, and I'm not an expert in this, but you can get it to overwrite some of those protections as the firmware, as the board is starting. And once you've overwritten one of the correct protections, then you're able to dump the firmware out. So I think, and again, I haven't done it, I think that works reasonably reliably. But again, not an expert on it.
No, sure, really interesting. But this is I've never thought of this before. Have you observed people targeting drone manufacturers, not the drones? And if so, who have you observed doing this? The answer is no, that's fine, but never
yeah, I mean, do somebody from Mossad in the audience? Is that?
Yeah, sure. I mean, raise your hand if you're from Mossad.
that's certainly something certain types of people would think of. I mean, a lot of the drone component manufacturers and drone manufacturers are from China. So so that in itself is an interesting kind of part of the landscape. We build drones. Fortunately, I don't think any of our drone facilities in the UK have been targeted, but we do.
But you do worry about it.
We do keep the locations out of the public domain for that reason.
And another, I mean, these are brilliant questions. Thank you, Anonymous. You're on fire. Any evidence of drones using public land mobile networks as their comms channel, either here or elsewhere? You know of?
There's been talk of it for sure. Evidence, I haven't seen the evidence. I would like to see the evidence. There is questions around the famous spiderweb attack in Russia, which the Ukrainians did against the Russian strategic bomber fleet, where they hid these drones within something like kind of shipping containers, and then got drivers to bring the drones near bases in Russia, and then they launched the drones. And of course, the question: how did they control them so far away? And the answer is probably through local cell phone networks. Again, I don't think it's not space-based communications. Is probably local terrestrial networks in Russia that they control them from. And there has been talk of that happening in cases in the UK, but again, not seen the evidence, so not sure.
The range and diversity of questions, Adrian, is quite remarkable, because so this one's about prisons. And I don't know, because we can't ask the anonymous questioner about whether this is about prisons in the UK or prisons just generally, because if it's prisons in the UK, I think there are all sorts of additional non-technological answers if you're reading the news about the state of the British prison system. But, you've talked about their use for importing drugs. Why don't they just jam them and jam it for cellular phone usage as well?
It's a great question. I don't know why. I don't know why they don't do more. With drones like DJI COTS drones, they also report the location of the operator as well. So if you're clever enough to build something that doesn't jam but actually receives, decodes the signal, you could just find where the operator is and then get a police car there very quickly. That's a very good mitigation. No idea why it doesn't happen there.
Yeah, and genuinely might just be because it's, in this country anyway, it's a struggling system, and if they're releasing people early, probably drones are the least of their worries. This one, it takes you back to the attacks on manufacturers, but it's a different aspect to that. And it applies in so many other aspects of this discipline of cybersecurity or drones. So long global supply chains, states have been tampering with hardware at source. So what do you think the real hidden risks, or where do you think, the real hidden risk sits? And how should they be handled before they're embedded into wider systems? A brilliant question.
Yeah, I mean, I think we do need to have a look at the proliferation risk. I mean, obviously, fingers crossed there is peace in Ukraine. Absolutely, we get that. But what happens after peace in Ukraine? Proliferation of technology has been developed in Ukraine by both sides is inevitable, and that's already happening. You can see what's going on in Latin America, but conflict situations in Africa, Middle East, other places, all of this technology is going to be flooding in. And how do we help our, allied forces, people who need to operate in those zones, to be safe, right? Because I think, as I mentioned, drones are not just flying pieces of malware; they're flying IEDs. What people were worried about back in Iraq and Afghanistan, roadside bombs. Don't have so many of those roadside bombs around the world anymore. They're flying IEDs that people need to deal with, and they will have AI with object detection. They will be, pre-programmed. You can just get them to go where you want to. So, how do we provide people with the systems that can quickly interrogate those flying IEDs to do, right, is that a friend or a foe? Okay, it's a foe. What am I going to do against it? Do I have to get out my drone gun, or can I do some kind of cyber attack against it to mitigate the threat? I think that's probably where we need to be looking at the moment. Excellent.
Well, that does perhaps slightly take us into the next question, and whether it's a question of attribution or digital forensics or something else, I don't know, but how can you evidentially prove, there's a debate around evidentially proving that a drone has dropped a payload. So can AI help solve it, or do you have any other thoughts?
I guess this is a sort of prison type scenario. I mean, good situation awareness of what is coming in and out through, radio signals and radar if available, or any other kind of tracking signals, of course, would be the best. But yes, AI could be helpful in terms of maybe retrofitting to CCTV systems. So if you can have a CCTV system, point it up, and then have AI built into that, so you can do drone detection and maybe drone tracking through existing CCTV system. Yeah, that could be an advantageous thing to have.
Another thing I've never thought of, so benign drone use, Amazon delivering in rural areas. Have you seen or thought about any evidence of criminals using anti-drone techniques against that sort of benign or even beneficial use?
I don't think delivery drones are quite there yet as a technology. But if there's money to be made, by stealing somebody else's Amazon deliveries. I mean, people steal them off of people's doorways. So yeah, I can imagine hijacking drones and getting high-value Amazon deliveries to come to you rather than to the recipient. Sure, there's probably easier ways to steal stuff, though.
I promise I'll stop soon because this is just gold dust, but it's very hard work for you at the end of a great presentation and a long day. So do fiber optic drones change the balance between UAS capabilities and counter-UAS systems?
Yeah.
And if so,
yeah, it's a good question. So so fiber optic drones obviously controlled from a fiber optic cable, so you've no emissions, so you've no way to jam a signal or to do a hijack against a command and control signal. They have a limited range, maybe up to 10 kilometers, something like that, and probably only have, maybe two ways. So they still would have GPS to do positioning. So if you can attack the GPS module, you've got a way into the drone system. The other way is you're back to kind of kinetic or other sort of means that you can take out a drone, like a laser type system, for example. And those are being developed. Those are going down in price. So all of the what were formerly missile-based systems, people are looking at using drones to counter drones, for example, which is a cheaper way to target the likes of fiber optic drones.
Thank you. Final Slido question, because Kerem's put their name to it. So do you believe AI will create truly autonomous hostile drones, or will human operators always be necessary, and how does that affect the risk profile?
Yeah, I mean, so absolutely, it will be possible very soon to program a relatively cheap and simple drone with a mission that is determined through an AI interface. You have an LLM that you can go, right, I want you to fly this mission, go off, fly to my local prison, drop this, fly back this route. If you see a police car along the way, fly that way. You'll be able to program that because it's all in software. The software controlling within the flight controller can absolutely leverage AI to generate its mission, and can leverage computer vision techniques to be constantly updated with what it's seeing, and will need no link back to the controller. Of course, you still need somebody to start it, and it gets back to, okay, well, why is somebody doing that? And the why then probably leads back to where is the person benefiting from it or launching the system from, and that's the clue, that's the link back to the case.
Fascinating. You're not quite done yet. I've got a final attribution question that's from me. Flying pieces of malware, I'm going to steal it. Lots of people in the audience might well steal it. Is that your phrase, or should we attribute it to somebody else?
It's my phrase. I'm going to claim it.
Brilliant. Adrian Nish, thank you very much indeed. Fantastic way to finish today.
Thank you.
Brilliant. Thank you.